All right, so here we go. Whoops, whoops, going too fast here. All right, so we got this. Now, let's go ahead and take a look at this little problem here. All right, which they don't give us any information on at all. All right, so it's got, okay, he's paddling. He wants to paddle, he wants to paddle with 17 newtons this way, and he's going this way with 15 newtons. All right, so 17 plus 15. I have no idea. I don't even know. The net force on the raft is pretty easy. In the x direction, well, 15 is 67. All right, let's just take a look at some of the forces in the direction. Now that I know what they want us to do, they're just looking at the vectors. All right, so sometimes we got to treat these like vectors. In fact, forces are vectors. So here's what they're doing. All right, so the guy's cruising along in his raft, and he's paddling this way, or in the p direction, 17 newtons, but he's being drifted this way. He's actually going this way, okay, with the C, I guess, is carrying him along at an angle like this, the current at 15 newtons, okay? But this is at 67 degrees. So, what's the sum of the forces in the x direction? What's the sum of the forces in the y direction? Well, sum of the forces in the x direction, not bad, is equal to 17 plus, now let's take a look at 15. 15 goes up like this at an angle of 67 degrees, right? That's not a very good 67 degree angle, but it does, so it's got an x component here, a of x, which would be 15 of x, and ay. So ax is equal to 15 cosine of 67. Okay, and f of y, so the forces in the y direction, are equal to 0 from this guy plus 15 sine of 67. Okay, and then the magnitude of the force of all the forces is equal to magnitude of x squared plus the magnitude of f of y squared, the square root of it. And then the direction it'd be going, the direction of the force would be the inverse tangent of sum of the force y direction or the sum of the forces in the x direction. That's all they're doing. Okay? They're going to spend like 30 slides doing that. So here's the x component, 23 plus 14. See, they didn't even tell me what the mass of the raft was or anything. Well, let's assume the raft now is 1,300 kilograms. 23.01 meters per second is accelerating in that direction. Now, those are accelerations. Those aren't the actual velocity. It might be cruising along nicely. Okay, then we get to the third law of motion, which is pretty straight and simple. For every action, there's a reaction of the same magnitude in the opposite direction. Whenever one body exerts a force on the second body exerts an oppositely directed force of equal magnitude on the first body. That's a nice way to put it. Because people say, for every action, there's an equal and opposite reaction. You can't be equal and opposite. You have the same magnitude, but you are not. But you're vectors. You are vectors. Vectors, vectors, vectors. So therefore, you cannot be negative 2 newtons in the negative x direction is not the same as positive 2 newtons in the y direction. In fact, if I add those two vectors up, I get 0. The net force would be 0. Okay. All right, so let's look at the homework problem. All right.